big round of applause for Kasper.
Hi, everyone. Did you have a great conference so far? Or it's actually ended now, so do you have a great conference? Shouldn't we get the organizer a big round of applause? And this doesn't work, apparently. Yeah, clap again, maybe. Okay, it's working. So I'm going to talk a little bit about breaking the multi-cloud barrier in a regulated industry. So as Johan mentioned, my name's Kasper. I work at a company called Lunar. I also have a lot of other different titles. So I'm also a CNCF ambassador. I organize meetups here in the city, and we also did like a sort of a Nordic thing where we try to gather all the meetup groups around the Nordics around the topic of cloud native. So that's the cloud native Nordics part. I do try to go out and speak as much as possible. It's been like a bit hard the last couple of years due to COVID, right? A new hobby this year, sailing. Needed something new to do. My wife thinks I'm a bit crazy. She doesn't really like to sail, so it's going to be interesting to see how that works out. Anyway, Lunar, if you're not familiar with us, we are sort of a fintech startup, now turned bank. We got a banking license in 2019. And we are now in multiple cities with tech hubs in 3 of those cities, in Aarhus, Copenhagen, and Stockholm. We have around 500,000 customers, got a lot of money. Apparently we are a unicorn now. Yeah, and as far as I understand, we are a double unicorn here in Denmark. So I don't know. So a lot of money in this game. From a sort of a tech perspective, we have a lot of numbers as well to show. So we do around 40 deployments in production per day on sort of an average. We have around 150 employees in tech, run some clusters, our multi-cloud, which we're going to talk a little bit about today. Yeah, different stuff. Just a little bit about the growth, because this also taps into sort of the story of why we need to go multi-cloud. So we've been sort of having, I would like to call it hyperscale growth, at least on sort of the Danish standards, I guess. So as you can see, in like 2 years ago, it just went like exponential up, both in customers, but also in number of employees. So alone last year, we hired around 300 people, started there. So it sort of requires a lot from the organization to actually make this scale and work from all sides, not only tech, but all parts of the organization. So it's interesting. Oh, I forgot, we also acquired a couple of companies last year, which is also why we are multi-cloud now. Lendify, we're completely in on Azure. I'll come back to that later. And Paylag is another sort of company we acquired last year. We try from a platform perspective to have this platform mission, and we really try to build a platform that empower our developers to make things easy for them, both in terms of being secure, but also make it easy to get things into production, and really try to just focus around building products for our developers so that they can be as efficient as possible. That is sort of our philosophy from the platform perspective, so that they can deliver value to our customers as fast as possible. So the way we build now is that we are on all three big clouds today. We try to select tools that are cloud agnostic and open source, so that we have a way to sort of connect these different clouds and figure out how we can align across the different providers. We really value the patterns around GitOps and reconciliation, which is, if you're not familiar with it, in Kubernetes we have this pattern of reconciliation loops where we have a desired state, replicas 5, we have an actual state, maybe 3, and then we have an agent that makes sure that the desired state is also the actual state. So that pattern is a pattern we really try to put in everywhere we can, because it makes a lot of sense for us. And then self-service platform, so build everything so that developers don't need to go to a central team and get all the stuff they need, but be able to get that themselves by clicking a button or whatever it might be. So we really like this concept of treating your platform as a product, but also treat developers as customers by applying a product mindset to the things that we try to build from an engineering and platform perspective. So multi-cloud, why? The elephant in the room, right? I mentioned this previously. We acquired this company called Lendify, and then, wow, this clicker is not working. But yeah, we acquired 2 companies last year, and we are set out to acquire probably another company this year. So it's really part of the Lunar growth strategy to buy whatever company sort of makes sense in the bigger picture of our journey. So it supports this growth strategy that we have, but it also gives access to fit-for-purpose technology. So we really want to utilize the best offerings for each cloud provider as much as possible. And it also, being a financial institution, we have this concept of we need to be able to move our stuff. We need to have an exit strategy if AWS or whatever provider we are on does not comply with the Danish FSA or whatever it might be. So we need to be able to shift as much as possible. So it also helps in that regard. But how do we then connect clusters or cloud providers? That is the big question, right? So we did some stuff initially. We tried out some VPC peering just between different clouds or between AWS accounts, and that works fine. Problem with VPC peering is that it's pretty hard to peer virtual networks in Azure where they have VPC in AWS, so that's not really working. VPNs is not really something we want to build anymore. So if we can not do that, let's not do that. But instead rely on more modern technology and utilizing mutual TLS as a way to do that. That would be really nice if that was an option. And we've been evaluating service mesh for a long time, and I'm sure many people have. It's a rather big sort of thing to take in, and there's a lot of complexity involved in adopting a service mesh. Do everybody know here what a service mesh is? Good. So if you didn't, service mesh is basically, if you've heard of Linkerd or Istio, it's tools where you have sort of the option to add observability or security or reliability features to your applications by inserting them at the platform level rather than at the application level. So you have another container that's sort of handling different parts of your system for you. And it looks something like this. At least this is Linkerd, which is the service mesh that we use. So Linkerd has this control plane, and we have a data plane. So that's sort of the 2 different sort of parts of a service mesh. If you start with the data plane, each pod in a Kubernetes cluster get a proxy injected, which then sort of handles all traffic from there on. And this is where you can add all of these, maybe add a circuit breaker, or you get instrumentation on that edge, or whatever it might be. And then that proxy talks to the control plane, so it talks to the destination service, for example, which knows about who can I contact. Maybe if there's some policies around I can't contact this one, then it gets it information from that service. The MTLS part, so when we communicate, proxies get a certificate, so each proxy has its own certificate. It gets that from the identity service, which is like a root certificate authority. And then there's an injector that makes sure that it can manipulate YAML files so that it can inject a proxy into all your pods. So that's sort of the high level of how a service mesh works. And yeah, you get your communication. It's going to be mutually encrypted once you sort of have a proxy in both ends. So now the service mesh proxy sort of handles that layer for you, which is pretty nice, but it also adds a lot of complexity. But that's only sort of in one cluster, so you can use service mesh within one cluster, but what about extending that mesh to multiple clusters? Now we have a cluster in AWS, we have a cluster in Azure, we have a cluster in GKE or in Google Cloud. How can we then sort of mesh those clusters together? Linkerd is pretty simple, and I wrote in the description of this talk, I want this to be something that you can take home and try it out yourself. It's super simple to actually run this yourself. So if you have a cluster in AWS and a cluster in Azure, whatever, you can install the Linkerd control plane, and then there's a multi-cluster control plane as well you need to install. And then you can link a cluster in one cloud with a cluster in another cloud by running this multi-cluster link command. And the output of that is basically Kubernetes YAML that you take from that cluster and move it to the other cluster. And it contains some information that we'll see in a second. And it basically spins up these 2 components in each cluster. There's a gateway, which handles all the traffic coming in. So whenever I need to talk from Azure to AWS, it goes through the gateway, and the other way, the other way around. And then there's a service mirror, and I'll explain that now. So the service mirror is basically a controller running in the West cluster over here in AWS. It watches the API server of Kubernetes over in the other cluster and listens for a particular annotation on a service object there. So if you're familiar with Kubernetes, there's this kind service resource. And whenever you put an annotation, in this case it's mirror linkerd.io exported true, you put that on, the controller will make sure that it replicates or mirror that service into the other cluster, which now makes that available for all services in that cluster to actually communicate transparently with a service running on the other side. So for the service perspective, it's transparent. It's just like communicating to a service just right besides this service. So yeah, it looks something like this. So now service B needs to communicate with service A. Service A adds this annotation. The mirror mirrors it to the other cluster, and then they are able to communicate mutually encrypted and all the way through, which is super easy and super nice. A little bit about the security sort of aspect of it. It works by Linkerd multi-cluster has this trust anchor, the root CA that we need to provide, which is shared between the different clusters. Then from that CA, we create sort of an intermediate certificate, which we give to an identity controller, which then use that to generate certificates in each of those clusters to each of those proxies, which is it's becoming a bit technical, but it sort of uses the service accounts in Kubernetes to actually create a certificate for each proxy. So we can easily validate and make sure that we are who we say we are when we are talking to each other because we are presenting the certificates. So cloud agnostic and open source, we use Kubernetes to bind our different cloud providers together. We create like a communication backbone using Linkerd to make sure that we're able to actually communicate across these different clouds. And yeah, Kubernetes is the foundation on which we build. So we started out with Kubernetes pretty early, and we've been building on that ever since. So this was very natural for us to just extend this into to Azure as Lendify we're running on. And Linkerd transparently then to connect these clusters. But we actually, before we acquired Lendify, we started out this journey just between AWS accounts. So we set out to actually try to do like, no, this was what we actually had before. So we were actually had this issue of, we had development and staging in a production environment, and we replicated our observability stack between each of those environments, which was pretty annoying, pretty complex. You probably know these systems are stateful systems, and it's becoming harder and harder the more data you get. So we really didn't want to have this model, but instead we wanted to move our tooling into like a central platform tool that we then could sort of put out into our different clusters, and that they could be consumers of instead. So we wanted to have this central cluster where we run Humio or whatever we were running there. And this was, Humio was actually the case. So we centralized our log management solution into the platform cluster down here, and then used Linkerd to connect all of these clusters, these environments, but in one-directional links, as you can see, because we didn't want it to be in a platform cluster, so you can just call this environment and this environment and this environment, but only have data flowing into the cluster. So we created the service, a Kubernetes service again, added the annotation, and now it's mirrored out into all the different clouds, and our log collectors there can then just transparently communicate and send data to that Kubernetes service running there, which is again super nice. It's transparent. There's no different from communicating to a service just besides this. So it works pretty well. But what about services running outside the cluster? If I have the problem of, if I have like, let's say an Azure app service or something like that, I need to be able to do a request to from another cluster. So now I want to request something from AWS to an app service in Azure. How do I then do that? Or if I'm from an app service, I need to be able to request something running in a cluster in AWS. How can I do that? So that was sort of the next problem we sort of encountered. And we created something we call the Backbone Gateway. Its responsibility is basically to handle this problem in egress and ingress of each cluster. We used Envoy. If you're not familiar with Envoy, it's a simple sort of server. It's a CNCF project as well. A lot of ingress controllers and stuff like that is built on that. I think Istio is also built on that, actually. But it works in this way where we have this simple repository called the Backbone Gateway. And if you're not, I'm not sure if you've heard some of my previous talks, I've been talking a lot about something called Shuttle that we built. But basically, just for the sake of this talk, Shuttle is just a simple abstraction. There's a YAML, Shuttle.yaml file in each repository, and in this repository, there's a Shuttle.yaml file as well. In that, we sort of make some abstractions, some ways of exposing different things. So what we did is that we made a simple way for developers to go in and add their resources. So in this case, this resource A, which could be an app service or whatever, needs to be able to receive a request from the other side, whatever that is. So the only thing they needed to do was to add a DNS name they got from the Azure App Service thing, call it something, whatever they want to be addressed on the other side, and then we handle the rest. So we built some configuration in Envoy that makes sure that whenever there's a request coming in, it will go out to that app service. And then we create different Kubernetes services in front. It works pretty well, and it's a simple abstraction for our developers to actually go in and add and expose their services in this way. They don't really need to understand the entire service mesh thing. It's just, I have this DNS name, it should be reachable on this name, and then it will be reachable on the other side using that name. The same thing for ingress. There we're really not using Envoy much because the project is still the Backbone Gateway project. It basically just generates an ingress object in Kubernetes that maps to a service that is mirrored. So in this case, service B, let's just take that, is a service that is mirrored from whatever's running on that side. And then we just create an ingress resource that points to that service. And then we sort of made the communication to go through an ingress controller, of course. So there's some automation underneath here. Within the next ingress controller, some automatic DNS that makes sure that whenever I create an ingress resource, I also get a private DNS in Azure or whatever it might be, and a certificate, and then that communication is sort of set as well. So back to the Lendify acquisition. So we now are seeing a lot of sort of requests about my service needs to be able to request credit scores or whatever from this Azure app service, and I'm running in AWS. How do I do that? And now it's just a matter of adding a PR into the Backbone Gateway project and mirror your service, and then you're actually able to, from AWS, to call over to Azure and call an app service and get a response from that service. There's a lot of sort of things that are hidden from the developers, but it works, and we try to create a simple abstraction. I'm not sure it's the complete right abstraction yet, but we'll see how it goes. When we created the Backbone Gateway, we also wanted to monitor these links, so we wanted to know exactly what was the latency between our different clusters in each of those providers. And there were some interesting findings is that whenever we, from AWS, call GCP or Azure, we see a latency around 30 milliseconds. So as you can see down here, we're all in the West Europe zones. But when we request from Azure or GCP back to AWS, there's a latency of 60 milliseconds, which is kind of odd. But that is what we see, and now we know, and now we can sort of make decisions based on that and where to place services. The last piece of the puzzle, managing clusters across clouds. I mentioned GitOps in the beginning. If you're not familiar with GitOps, there's these sort of principles. You express a desired state. You do that in a Git repository usually. It could be other versioned storage as well. And then you have these agents that watches or sort of looks for the desired state and make sure the actual state is also what you desire. So we have this reconciliation loop going on all the time. And when we sort of adopted this multi-cloud Kubernetes, it was fairly simple to just utilize GitOps as we already had. So in our config repository, and that's actually this slide. So we have one repository where we have different directories. So you can see GCP prod, AWS prod, Azure prod. It's just a directory in a Git repository. And in each of these, there's a sort of a folder structure of how things should be. But it's basically just YAML files in a directory, in a repo. And then in each of those clusters, whether it's in Microsoft Azure, or it's in AWS or GCP or Google Cloud, there's an agent running there that watches a particular folder and just applies whatever is in there. So that is super simple for us because we have built all our tooling around. When I do a release, the release is actually just a commit into that repository, and then the agent makes sure that whatever is in the repository is also the actual state. So that is really, really nice to get that, because we can then get from a Git repository, we of course get all the, I think that's actually the next one. We get all the audit trail of the Git log. So whenever a developer releases something, it's basically just a commit into this repository, which then gives an audit log saying, I just released this, whatever service it was, into this environment. It's noted the time was at this time. And we get that trail for all our environments, which is super easy and super nice, and it just ties into how we were doing things already. It also sort of enforces least privileged access, because our developers are basically just interacting with the Git repository and not the actual production systems, which is also a nice thing, being a financial institution. GitOps allows us to treat clusters as cattle, because now we have all the desired state in the Git repository in the directory, so it's fairly easy with some modifications, to start up a new cluster, add the agent to that cluster and point it back to the desired state and just have it recreate everything. We did some experiments, or not really experiments, but we did a failover of our production cluster in December, which took 1.5 hours maybe to actually get everything up and running and doing like a gradual rollout of traffic between clusters. And it was easy because the state is defined, and then we of course have some services that need special care, but in essence we want to come to a point where we can point an agent to a place in a directory, and it should be able to figure out how to get back. And GitOps ensures that process for release is the same across cloud providers. I mentioned that as well. So we have a central CI. It builds an artifact. It builds the Kubernetes YAML. And then we have this release manager tool that makes sure to commit into the right place in a Git repository. So there's no special pipeline in Azure or in Google or whatever. It's the same across multiple clouds, which of course hopefully should save us some time, not building and be experts in all different providers, and we can choose the right tool for the job, right? So we build multiple clouds, or we use multiple clouds. We try to really be cloud agnostic and choose open source with Kubernetes and Linkerd. Reconciliation and these agents is Flux at the moment to apply the configuration from the Git repo, but we also want to add more interesting things like crossplane, which is also really just where you define an S3 bucket or whatever in YAML, and then you have an agent that makes sure whenever it sees this bucket, it will reconcile and create the bucket for you and provide maybe a secret back or whatever is needed. So that is something that we are exploring and looking into at the moment. And self-service platform. We talked a little bit about developer productivity, but I really want to highlight that making it easy for developers to get their stuff and not be dependent on another team is very important. So we try to do that using Backstage, also been a topic we've been discussing, at least with some this conference, and our own built open source tool called Shuttle. It works really well. And of course, there is some places where it makes sense to actually go deeper in a cloud provider for us, and whenever that makes sense, then we just do it. We try to select open source managed first, but if that is not the case, then choose a proprietary solution. That's totally fine. So the end goal, should developers be able to use the cloud as they see fit? Should we do federation across all 3 clouds or 5 clouds or whatever we have at some point? I really don't think there's a lot of considerations when sort of going into multi-cloud, because latency, as we talked or saw earlier, is definitely a thing, right? So if you have a user coming into AWS, waiting for a reply or response from a service running in Azure or whatever, then that's probably not a good way to do it. So what we want is to extend our sort of asynchronous communication to go across clouds, so that I don't know, a credit score model or whatever needs to run on Azure can do that based on an event or whatever it might be. So that was actually answering question number 2. And will you at some point consolidate and move everything into one provider? Maybe. Right now we are trying to move everything into a cluster as initially, and into a container, because then it's easier for us to move them into AWS if we want that. It's not really decided yet, because it makes a lot of sense also the things that they're utilizing on Azure. So yeah, it's we'll see. And I think that's it.
I think we have time for a single question, if you want.
Sure.
If you're not complaining, and thank you. Do we have a question on the second to the front row? Can we get a runner for them? You can also get this one. I mean,
you are the runner.
I'm the runner.
So when the new Kubernetes version comes out, which is absolutely all the time, then how smooth is the process for getting that, into all of your different clouds?
It's not that smooth at the moment. We are looking into cluster API to actually sort of aligning the way we spin up clusters. But right now it's a bit of a pain. Also, so we are currently adopting more and more managed Kubernetes solutions, but the difference between managed Kubernetes solutions with core DNS or kube DNS, or which CNI should I use, is also different, and sort of the available CNIs is also different between the different providers. So we are looking into different options of how we can get a more similar setup across. So cluster API looks very interesting, because then we can apply this reconciliation pattern again to our clusters. So if I need to upgrade a version, I just need to go into a repository and put in this new version on the different YAML files, and then an agent will make sure it's being upgraded. So that's what we're looking at least.
Thank you. Thank you so much. Another big round of applause for Kasper. Thank you.